Well, welcome back to another lesson in our Common Core series. Tonight's focus is on systems of linear equations. So here's what it means to do. To solve a system means to find all the sets of values that simultaneously make all the equations true. And there's two methods to do this, substitution and elimination. Now back in Common Core 1, Algebra 1, you focused on this quite a bit. So we'll review a simple one from Common Core Algebra 1. So like I said, there's two methods, elimination and substitution. I'm going to start with elimination. And what does that mean? Well, just kind of like the word says, my goal is to eliminate one variable. So let's make a note. This is referred to as a 2x2 system of equations. Why do you think I'm calling it a 2x2? Well, how many variables do you have? That would cover my first two. And how many equations do you have? 2. So 2 equations, 2 variables. So I have a 2x2 system. Alright, so I'm just going to refer to this as equation 1 and equation 2 as I go through. So remember, your goal is to eliminate either the x's or the y's. And it really doesn't matter. You can't go wrong. Let's say you want to eliminate the x's. That would mean I need these two numbers to be the same number but different by a negative sign. So here's what I'm going to do. I'm going to take equation 1 and I'm going to multiply it by a negative 2. And then I'm going to take equation 2 and I'm going to multiply it by a positive 3. Now why did I do that? Well, look what happens. Negative 2 times 3 is negative 6, and 3 times 2 is 6, and a negative 6 plus a 6 cancel and eliminate. So again, you could have eliminated the x's or the y's. If I was going to eliminate the y's, I'd probably multiply this equation by negative 2, and then they would eliminate. Anyways, I picked the x's, so I'm going to go through with it. So I'm going to get negative 6x minus 4y equals 18. And here I'm going to get 6x plus 3y equals negative 21. All I did was take my numbers and distribute. And remember, the whole goal was to eliminate something. So here's where the elimination comes in. If I add these equations together, guess what? Negative 6 plus 6, eliminated. So now I have negative 4y plus 3y is negative y equals negative 3, and y equals positive 3. Alright, now you're not done until you've solved for all the missing variables. Well, remember this was called a 2x2, so you have 2 variables to solve for. So if I know y equals 3, I can take this and I can either go back and substitute it into equation 1 or equation 2 to figure out the x value. It doesn't matter, just pick your favorite one. I'm going to go with maybe equation 2. So I'm going to say 2x plus y equals negative 7. And I'm going to substitute my y in. So 2x plus 3 equals negative 7. 2x equals negative 10, divide, and x equals negative 5. Now you've solved your system of equations for x and for y. So again, this was called a 2x2. This is what we did back in Algebra 1. We're going to spice things up a bit. Alright, we're ready to get into it. A 3x3 system. Sounds a little crazy. That means we have 3 variables and 3 equations. So let me give you the first equation. 2x plus y plus z equals 15. 6x minus 3y minus z equals 35. Negative 4x plus 4y minus z equals negative 14. And again, I'm just going to label these 1, 2, and 3 so I can keep them straight throughout the video. Okay, now you can't go wrong. You pick any 2 equations you want. It really doesn't matter. Maybe you want 1 and 2, maybe you want 1 and 3, maybe you want 2 and 3. It doesn't matter, guys. Just pick 2. I'm just going to pick the first 2 to start with. And we're just going to rewrite. And yes, I know this takes a little bit of time, but welcome to algebra. Now, there is a very smart variable to eliminate here. Can you see which one it is? Is it the x, the y, or the z? I'm hoping you're seeing right away that the z is the smart one, because what's a positive z and a negative z make? Well, they eliminate, they cancel out, they make nothing, zero, zilch. So z is the best one to eliminate. Now, it doesn't mean you have to, but like I said, it's the smartest one, because I don't have to multiply either of these by anything, I just need to add them together. So I'm going to get 8x minus 2y, those eliminated, equal 50. So now I've reduced my 3 by 3 into a 2 by 2, because I have two variables. Okay, now I have to get one more set of equations, and basically you can pick anything you want except the one you already did. Maybe you want to pick 1 and 3, maybe you want to pick 2 and 3. Again, it doesn't matter, you can't go wrong. I'm going to pick, I don't know, 1 and 3 now. 2x plus y plus z equals 15. And we'll go through row 3. Negative 4x plus 4y minus z equals negative 14. Now I did do that with a little strategy, guys. Again, if my goal is to eliminate z here, you have to eliminate the same variable. So I have to eliminate my z. Look how smart it was to choose 1 and 3, because what happens again? Positive z and negative z get eliminated. So I'm going to get negative 2x plus 5y equals 1. Okay, so now I've officially broke down my 3 by 3, and I've made it into a 2 by 2. So now we're going to take those two equations and solve this 2 by 2 system. Okay, now I can't just add or subtract the way it is, because notice, again, these x's don't eliminate and these y's don't eliminate with a little fun. Alright, so again, it doesn't matter if you choose to eliminate the x's or the y's. Pick a variable and decide what you're going to multiply by. So I'm thinking, I'm going to call this row 1 and row 2. I'm thinking I could multiply row 2 by the number 4, and when I do that, that would get me a negative 8x. And a negative 8x and a positive 8x would eliminate. So I'm technically multiplying the first row by 1 and the second row by 4. So 8x minus 2y equals 50. I'm going to multiply this row by 4, so negative 8x plus 20y equals 4. And I'm going to add those together. That gets eliminated. So I've got 18y equals 54. Divide out my 18, and y equals 3. Now you're not done until you go get every unknown. First I have y equals 3, so now I have to go get x. Now, think about this. Would you use the 2 by 2 system or the 3 by 3 system to go get x? Well, if you try to do it in the 3 by 3 and you know y, you have two variables. You can't actually go back to that 3 by 3, so you got to start back and go to the 2 by 2. So I'm going to plug 3, and again, it doesn't matter. You can plug it into 1 or 2. Pick your favorite. It really doesn't matter. I'm going to plug it in the first one. So I'm going to say 8x minus 2 times 3 equals 50. 8x minus 6 equals 50. That's 8x equals 56. So x equals 7. Now I have x, I have y, and I can go get z, which means I do need to use one of those original equations. And I'm just going to pick, I don't know, that first one. I think I remember it. 2x plus y plus z equals 15. So I'm going to go 2 times, what was x? 7 plus 3 plus z equals 15. So that's 14 plus 3. So I get 17 plus z equals 15. So z equals negative 2. And there you have it. You've solved a 3 by 3 system of equations. Yes, it takes a little bit of time, but that's okay. We're going to definitely give you more time on the next test here. So what does that mean? Well, that means if my x is 7, my y is 3, and my z is negative 2, I should get 15. And you can check. If my x is 7, 3, and negative 2 in this equation, you should get 35. And same thing here. And it's a quick, easy check. You can never go wrong. All right. Whew, let's take a deep breath and get ready to try another one. All right, so we've got another exciting 3 by 3 system to solve. Again, 3 by 3 just means 3 equations and 3 unknowns, x, y, and z. So I'm just going to label these 1, 2, and 3 to keep them straight. All right, now remember, it truly doesn't matter which 2 you begin to start with. So I'm just going to pick 1 and 2 to begin with. And I can't stress enough, this takes a lot of time. You don't want to rush through this. One mistake botches the whole thing up, so really take your time here. Okay, so now you just have to choose to eliminate the x's or the y's, and remember, or the z's, and it really doesn't matter. I'm going to pick, I don't know, the y's, and again, no rhyme or reason. What do I want to multiply the top and bottom row here to make those y's disappear? Well, I'm thinking if I multiply the top by a -4, that would get me a -4y, and a +4y eliminate. So I'm technically multiplying that bottom row by 1. So I'm just going to take my time. I'm going to get -4x. I already messed that up, so really take your time. -16x minus 4y plus 12z equals 24. On that bottom row, I'm just multiplying by 1, so it's going to remain the same. Okay, and remember, the whole point was to eliminate a variable. So let's see. -16 and -2, that gets me a -18x. Slam, bam, those will disappear. We love that. Plus 14z equals 62. So I've condensed the equations 1 and 2 down to a 2 by 2 system. Now I have to pick another pair. You just can't pick the same pair, obviously. So I did 1 and 2. Maybe now I'll do, I don't know, 1 and 3. So I'm just going to carefully rewrite those. Now remember, the only thing is though, you have to eliminate the same variable. Now I got nice and lucky here, maybe a little strategy. What happens right away? I don't even have to multiply row 1 or row 3 by anything because these y's, when I add them, are just going to slip away again. So I'm going to end up with, let's see, that's 9x, slam bam, those are gone, minus 10z equals -25. So I've taken my 3 by 3 and I've condensed it to a 2 by 2. And now I'm just going to take that 2 by 2 and that 2 by 2 and put those together. So I'm going to make my 18x plus 14z equal to 62, and 9x minus 10z equal to -25. Okay, so now again I have to choose to eliminate the x's or the z's, and it doesn't matter. Whatever makes you feel better. Now I think the x's might be a little easier, so I'm going to go with that. I'm going to multiply, let's see, if I multiply this bottom row by -2, whoops, maybe a +2 would be a better choice. A +2, then I would get a +18 and a -18, and they would disappear. So I'm technically multiplying the top row by 1 and the bottom row by 2. So that's going to leave me as -18x plus 14z equals 62. And here I'm going to get 18x minus 20z equals -50. All right, slam, bam, those are gone. So I'm going to leave myself with a -6z equals 12, divide by -6, and z equals -2. Whew. All right, once I have one variable, I have to go back and get the missing variables. So I'm going to go back from my final answer into my 2 by 2 to get the x. Now again, it doesn't matter which one you plug into at all, just pick one and go for it. I'm just going to pick the top one. So I have -18x plus 14 times -2 equals 62. So that's -18x minus 28 equals 62. -18x equals 90. Therefore, x equals -5. Whew, okay, so I have my z, I have my x. Now I have to go get my y, which means I have to use one of those original equations from the 3 by 3. And again, it doesn't matter which one you pick, I'm just going to pick row 1. So I'm going to say that's 4 times -5 plus y, what was that, minus 3 times z, so 3 times -2 has to equal -6. So that's -20 plus y plus 6 equals -6. -20 plus y equals -12. Y equals, let's see, I get a +8. Now again, how do you know if you're right? Well, now that you know x, y, and z, just take them and plug them in. It's a quick check. If I take that original equation, 4x plus y minus 3z equals -6, all I got to do is substitute my x, y, and z in and really hope that I get -6 as an answer. So let's see. I'm going to do 4 times -5, which is -20, plus my y value of 8, minus 3 times -2 is going to get me a +6. Does that equal -6? So that's my check. So that's -20. 8 plus 6 is 14. It gets me a -6 equals -6. Checks out in row 1. Whew, all right. I think we've got time for one more. All right, now in this 3 by 3, tried to have a little fun with you. Notice that all the variables aren't lined up. And that's a big problem. You have to make sure, you have your 3 variables and it's equal to the constant on the one side. So my first goal is just to rewrite this silly equation. So I'm going to say, break that off there, 4x, I'm going to bring over that 2y, so minus 2y plus 3z equals 23. The second one looks good. We'll just make sure they're lined up. X plus 5y minus 3z equals -37. Okay, now I just, again, got to be careful. I'm not adding this to the other side. I'm just, switching these two spots. So -2x plus y. Now I am going to add that 4z over. Has to equal 27. So the first thing I had to do was clean it up. Put the x, y's, and z's in the correct spot. Now I think you should make a note in your book here. If a variable is missing, just like in long division, you would have to put in a 0 placeholder. So you would have to do like 0x or 0y or 0z. You definitely want a placeholder if something's missing. All right, so I'm just going to label these 1, 2, and 3. And again, it doesn't matter what 2 equations you pick. We'll just pick one and go for it. So let's see. I think I'm just going to go with 1 and 2 and rewrite those out. Okay, now again, you can pick any variable you want to eliminate. There's actually a very smart one here, and that would be the x's, or the z's, I'm sorry, because 3z and -3z, slam bam, are gone and eliminate. Now, just for the heck of it, I'm going to pick a different one just to show you that it really doesn't matter. Let's say I want to eliminate the x's instead of the z's for some reason. Maybe I didn't catch that they eliminated right off the bat. I'm going to multiply this bottom row by -4 and the top row by 1, because that would get me a +4 and a -4x, and they would cancel. So I'm going to leave that top row. And again, I'm just showing you this in case you didn't see that the z's cancel and you wanted to try a different variable. 148. Okay, and it really won't matter as long as you go carefully with your math. Slam bam, those are gone. So that's a -22y plus 15z equals 171. All right, so I'm going to grab another pair of equations. Again, it doesn't matter. I'm going to go this time with equations 1 and 2. I'm sorry, I just said 1 and 2, but I meant 2 and 3. All right, and since I eliminated the x's there, I have to eliminate the x's in this one. So I'm going to multiply the top row by 2 and the bottom row by 1. And what am I going to get here? I'm not going to change those, so 2x plus y plus 4z equals 27. All right, add them up, slam bam, those disappear. I get 11y minus 2z equals negative 47. All right, now put your 2 by 2 system together. And choose to eliminate the x's or the y's, or sorry, the y's or the z's. And it doesn't matter. I'm going to tell you right now, I'm going to do the y's, and I want you to pause it. You do the y's and see what you get. Good luck. All right, so again, you should have paused it on your own. Don't cheat yourself. I got z equals 7. Once I have z, I'm going to substitute it back into one of these equations and go get my y. I ended up with y equals negative 3. And now that I have y and z, I have to go back to the 3 by 3 and substitute that in. And I think I get x equals negative 1. And again, a quick check, plug them back in. 4x minus 2y plus 3z has to equal 23. Let's see, 4 times negative 1 is negative 4, plus 6 plus 21. What is that? 27 minus 4, 23 equals 23. And I know it checked. Well, that does it for us. We're going to get some great practice. Remember, it's not about speed tomorrow. Really slow down. We're going to use a lot of scrap paper, and just take your time. And good luck. Have a great night.